let's do our counting methods brain dump. So we're going to start where we started in our notes, fundamental counting principle. So what is it? It's when we have a task that can be broken down into stages. So this might be getting dressed in the morning. You have to choose your shirt, your pants, your shoes. This might be making a sandwich. You have to choose your bread, your meat, your cheese, your vegetable. If it can be broken down into stages, it's going to be your fundamental counting principle. And maybe I have M ways to do stage 1. Maybe I have N ways to do stage 2. Maybe I have P ways to do stage 3. And so on and so forth, depending on how many stages we have. And our fundamental counting principle just states to find your total number of outcomes. You just take your ways to do stage 1, times it by your ways to do stage 2, times by stage 3, times by however many stages you have. So because we have to do one stage and another, so you have to choose the shirt and the pants and the shoes, and means multiply. So this is really common with choosing your outfits, really common with food combinations. So maybe I have to choose a appetizer, an entree, a dessert. Maybe I have to make a sandwich. Maybe I have to choose like a cookie, a meal, and a drink. Those are all kind of your fundamental counting principles. And then we learned about this factorial notation. It's when we were really excited about numbers. So it was always for a positive integer n. An n factorial is just a product of all of the positive integers less than or equal to, positive integers less than or equal to n. So what that looks like is we go n factorial is n times by whatever is 1 less than n times by whatever's 1 less than that, all the way till we run out of positive numbers. So we finish a factorial when we reach 1. So for example, if I wanted to do 5 factorial, well, this is 5 times by 4 times by 3 times by 2 times by 1. Remember, in our calculator, if we have the kind of older style calculator, we go math, we're going to go over to probability. So we hit our math button, we scroll over to our prob, and we can see number 4 is our factorial. So we would want to put our number first. So because I didn't have a number there, it's just going to pick whatever number I was before. So I'm going to go back, change that to 5 factorial. And there we go. It is 120. Remember, if you have the newer calculator, you can go alpha window, and there's your factorial right there. So you would just hit 9. Again, I forgot to put the number first, so I'm going to go back, change that. still 120. There is a special case for factorials, and that is the fact that 0 factorial equals 1. And you cannot factorial a fraction, decimal, or a negative number. Because none of these can I count down to 1. So if we try to say factorial a fraction, so maybe, or a decimal, so 0.5, I'm going to try to factorial that. Oh, your calculator will actually do it, which is funny. This is not actually possible. Mathematically speaking, we cannot factorial a decimal. So that's really awesome that your calculator does that. On your diploma, if it says which one of these is undefined, you would say anything that is a fraction, a decimal, or a negative number. I find that really funny that your calculator does that. Should not do. Alright, so before we go into solving counting problems, we're going to break it down into the 2 main counting problems. Permutations, order matters. Combinations, order does not matter. So this one is an arrangement of specific objects. So this is a key word. If you ever see arrange, you know that it's a permutation. These are things like passwords, codes, very common with license plates. When you're ordering letters, these are all situations where you're arranging something, so these are your permutations. And there's kind of 3 main types of permutations you can have. So you can have a permutation of all objects. So maybe I want to organize all of the letters in the word. What's good? Well, actually in the word word. So because I'm ordering all of the letters in the word, the number of outcomes you can have is 4 factorial. So permutation of all objects is your number of objects factorialed. This is when you have not allowed repeats. So if I was doing like a password or a code and I'm doing all objects, that can repeat. So maybe I'm doing a 4-digit code. Well, I have 10 digits to choose from the first number, 10 digits for the second, 10 digits for the third, 10 digits for the fourth. So that means I have 10 to the 4 outcomes in this specific example. So we have to pretend if we can't repeat, we have factorial. If we can repeat, then we repeat that number over and over again, and we end up with a power. Sometimes we have permutation, where you just pick some objects. So maybe I want to know how many 2-letter combinations. Sorry, 2-letter, don't want to use the word combinations. So maybe I want to know the number of 2-letter arrangements again, I can make from the word word. So this is when we're going to use NPR, where this is your total and this is what you want. So in our particular case, I have 4 total letters to pick from, and I'm only picking 2 of them. And remember, in our calculator, if you have the old style, or actually both styles, you can go math over to probability, and you can see number 2 there is NPR. Again, I forgot to put a number into my calculator first. Because I have the new style, it's going to ask you. The old style, you're going to just have to replace whatever was before. So I'm going to go NP2. And there we go. There's 12 different combinations that I could have. The last case is I could have permutation with identical objects. So maybe I'm arranging all the letters in the word tattoo. So you can see in the word tattoo, I have repeated letters. So I have 6 total letters. I have 3 T's and I have 2 O's. So to do this permutation, we'd say I have 6 factorial over 3 factorial times by 2 factorial. Because changing those T's around, I'm not going to be able to tell that I changed them around. So permutation with identical objects, you always go your total. Then you divide by however many repeated things there are. This one is not on formula sheet. You have to remember or brain dump this one. So we have to remember or brain dump this one when we have identical objects. Its counterpart is we have combinations. So combinations is when I am just selecting items. And order does not matter. So this is for committees when I have no specific roles, when I'm not assigning a president, vice president, or treasurer to one specific person. Remember, those roles are person specific. If I'm just putting groups of people into like a group in marketing and a group in financing, those groups, the order doesn't matter. But if I have one person being president, one person being vice president, then order matters. So very common with committees, with hands of cards, common with food, anything where you can't tell if you change something. So if I get a sundae and it has chocolate, vanilla, and strawberry ice cream in it, I don't know what one came first. I just want to know that all 3 of them are in my bowl. So this one has 2 ways of writing it. We can say NCR, or we have NR. Both of these mean n factorial over r factorial and minus r factorial. This is in fact on your formula sheet. Don't necessarily have to remember it because your calculator can do it. So in that same place where we found our permutations, so we're going to go over to math, probability, you can see there's your combination as well. So one of the things that they like to do with combination is the at least and at most types of situations. So 4 men, let's say 5 women, and I want a committee of 4. Maybe in this committee of 4, I want at most 1 man. So when we have at most, we want to start at the number they give you, that 1, and we want to count down till we run out of options. So in this case, I run out of options when I have 0 men. So my option 1, I have 1 man, which means I have to have 3 women. Or option 2, I have 0 men and 4 women. How this looks like with our combination, well, of my 4 men, I want to choose 1. And of my 5 women, I want to choose 3. Or I have my 4 men, I want to choose 0. And I have my 5 women, I want to choose 4. So you can see this is where we get our cases and our or. Or means add. The other side of this, the one that they like, is when we have at least. So at this one, I want at least 3 women. So with at least, we start at the number they give us and we count up till we run out of options. And because this is a 4-person committee, we're going to run out of options when I have all 4 women, because I can't have 5 women in my committee of 4. So in this case, my option 1, I have 3 women, 1 man. Or my option 2, and we could have option 3, option 4, option 5, just depending on how many or where we started with at least or at most. So in this one, we have 4 women and 0 men. So you can see it's going to look very similar to this one. So I have 5 choose 3 and 4 choose 1. Or 5 choose 4 and 4 choose 0. So be aware of those at most and at least, because they're going to change our cases. You have to do all of the cases that pick those specific situations. All right, so now that we have all of the parts, we have to break this down to how do I solve a counting problem? Well, step 1, biggest thing, read the question carefully. You really have to understand the question in order to figure out what you're going to do. Am I using fundamental counting principle, permutations, or combinations? So read the question carefully, and you really want to highlight those keywords. So does it say arrange? Does it say password? Does it say codes? Is it talking about license plate? Do we have decks of cards? Are we talking about food? Look for those keywords and highlight them. All right. Once you've read the question carefully, found those highlighted words, then you have to ask yourself, does order matter? If you answer yes to this question, then you know you are doing a permutation. If you answer no to that question, then you know you're doing a combination. All right. So if the order matters, do we have identical objects? If we do, then we're doing that n factorial, a factorial, b factorial, c factorial. Are we using all objects? If we are, then we can use n factorial, or maybe we're allowed to repeat, and it's your number to your power of however many things you have. All right. Maybe you're only using some objects. In this case, you can use NPR. Right? If it's combination, do we have at least, at most? Do we have to do cases? So we're trying to figure out, do we have or cases where we have to add things together? And of course, you always want to, for any of these questions, start with your restrictions. If you start with your restrictions, then you know that they are out of the way, and you can use whatever is left over. So if it says it has to be an even number, start with putting that even number where it is. If it says you can't use repeats, what does that mean? If it says I have to put the tallest person in the middle of the lineup, what does that mean? Look for those restrictions and deal with them first. All right, so there's your counting methods. Again, try the questions, brain dump on your formula sheet, and anything else here. This is just a general overview. There's some other things that you might have to add depending on what you need to remember.